Okay, page 5, folks, here we go. Starting with number 14. Okay, and it says, with the given information, which lines, if any, must be parallel and provide a theorem to support your answers. So with A, what it's saying is, if angle 1 was congruent to angle 4, and we can't actually do this one because there is no angle 4 in this picture. So guess what? We don't have to do part A. Okay, there is no angle 4 in this picture, so let's just forget about it. Okay. Good news, bad news with part B. Part B also involves a mention of angle number 4, but guess what? Just like before, there is no angle 4, so we're not going to talk about B either. Okay. There is, however, angle 1 and 3, and so we can talk about part C here. If angle 1 is congruent to angle 3, then which lines must be parallel? So if angle 1 and angle 3 were congruent, the transversal that creates them is this line E right here, and line E is intersecting line V and line C, right? Mm-hmm. So if these two are parallel, then line V must be congruent, or line V must be parallel to line C. Okay. Part D, if angle 1 is congruent to angle 2, then which lines, if any, must be parallel? Well, angles 1 and angle 2 here, those are formed by this transversal, line V, and they intersect lines E and T and make these these are corresponding angles, right? So I should have said here, V and C, this is because these are alternate interior. I should have, back in part C, this works because 1 and 3 are alternate interior. This works, E has to be parallel to T because 1 and 2 would be corresponding. Okay, so that's, I think, the full situation for question number 14. Too bad we couldn't do part A and B, but whatever, I'm over it. Okay, question 15. Given that OWT is congruent to XIS, which of the following statements are true or false? And then make them true if they are false. So if OWT is a triangle, XIS, okay? If this triangle is congruent to this, then all the corresponding pieces are congruent, okay? S and T, so part A. Is angle S congruent to angle T? Well, yes, because in the naming of these triangles, S and T are in corresponding positions, so that's true, okay? Part B, angle X and angle W. Is angle X congruent to angle W? Well, again, if we look, this time they are not in corresponding positions, so it is not necessarily true. It is not necessarily true that those angles are congruent, and so we have to say false. But then let's change this to make it true. Well, what would X definitely be congruent to? Well, X would definitely be congruent to O, right? So angle O would make that statement true. Okay? Alright. Part C. Segment OW is congruent to segment XI. Is this true or not? That's true. OW, right, corresponds to XI. So this is true. And last but not least, part D. OT is congruent to IS. Is that true? OT is not corresponding with IS, so this is false. And this segment here would need to be changed to, let's see, OT at the XS, and that would make it true. Okay? So that's a wrap then for question number 15. Okay? One more on this page, and that would be number 16. Let's take a look here. 16 about. so number 16. Aside from the, okay, I remember these. Okay, we've got 4 situations. Okay, so this top one looks something like this, and it says, what else would you need to prove, or what would you need to show in order to show that this triangle and this triangle were congruent to each other by the side-side-side congruence postulate? And what it tells us, what's given is that those 2 sides are congruent. Okay. We also know that since the triangles share this side down the middle, the reflexive property allows us to deduce that those 2 sides are congruent. So the last bit, if we're going to use side, 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 would be this side, which is AB, would have to be congruent to this side, which is AD. Okay, so if we're going to show that side, side, side is the way that these 2 triangles are congruent, AB would need to be congruent to AD. Okay, that's part A. Part B. Okay, we've got the famous kind of bow tie situation, and it gives us these 2 angles are congruent, and we're going to try to use ASA this time to show that these 2 triangles are congruent. Well, it's given us that these 2 angles are the same. That's cool. We know also that these are vertical angles, so we can deduce from this picture that this angle is congruent to this. And so the last bit is we need a side, and we need to have the included side here and here, right? Okay. So what is the name of this side here? Well, this side here is AE, right? AE here would need to be congruent to ED here. Okay. If AE was congruent to ED, then we've got congruent triangles by angle side angle. All right. Number C, you know what I mean. This picture looks almost exactly the same as the one in part A, and that was terrible. Okay, pretty close. It's got this thing down the middle. And so now we're hoping to use SAS. So what's the situation here? We're given that those 2 are congruent. We know by reflexive property that that side down the middle is shared between the 2 triangles. So what is the angle that we would need? Well, we need these included angles here. Side, angle, side, side, angle, side. So this then would be angle 1 needs to be congruent to angle 2. Yeah? And last but not least, part D, the HL theorem. It looks like this, like this, like this, this, and boom. We know that's a right angle, and we need this, and this. Okay. HL. Okay. HL is the hypotenuse leg theorem. We can only use this if we have right triangles, which we do. Okay. Well, both of these are right triangles. We've got a pair of legs. This leg is congruent to this leg, so we need the hypotenuses also to be congruent. We need this to be congruent to this, which means AC must be congruent to ED. And then you've got 2 congruent triangles by the hypotenuse leg theorem. All right, that is a wrap for page 5. 2 more to go. I'll see you then.